Welcome to Basic Mathematical Analysis class. Today we will discuss about existence of root 2. That is, we have already proved that there does not exist a number that is a rational number uh, p by q form which is equal to root 2. But there exists a number root 2. So in this section we will prove that there exists a real number root 2. 2.4.7 theorem. There exists a positive real number x such that x square equal to 2. So the proof structure is we will first of all create a set. Let S equal to set of all S belongs to R such that 0 less than or equal to S and S square equal to 2. So this is our set. S belongs to R such that 0 less than or equal to S, capital S, such that 0 less than or equal to S and S square equal to 2. Oh, sorry, not S square equal to 2, S square less than 2. Okay, S square less than 2. Now, this set is non-empty. What's the reason? Now, our set S is non-empty. Reason is we can easily point out some numbers, right? Can you name one number? Since 1 belongs to S. 1 is a number, right? Because 1 square is less than 2. Also, my S is bounded above. Am I right? Because S square is less than 2. So any number whatever I will take, that should be less than 2. So it is bounded above. Therefore, we have studied that a bounded above set should have a supremum in R. Okay. So completeness property. Bounded above by 2 we can have. Since t greater than 2, then t square is less than t square is greater than 4, right? T greater than 2, then t square is greater than 4, which implies t does not belongs to S. Then by supremum property, of real numbers, S has a supremum in R. Set S has a supremum in R. So we will take the supremum as some x. Let x equal to supremum of this S. Now your x value is greater than 1 because 1 already a number. Then either your supremum square x square is less than 2 x square equal to 2 or x square greater than 2 by law of trichotomy, right? Now we will prove that this x square equal to 2. For that, what we will prove is x square less than 2 is not possible, and x square greater than 2 is also not possible. So only possibility should be x square equal to 2. So first assume that your x square is less than 2. So first we will assume that x square is less than 2, and we will prove that this is not possible. Next, what we are going to do is we will assume x square is greater than 2, and that also we will prove such a case is also not possible. So the only possibility should be x square equal to 2. That's our uh, proof structure. So first assume that x square is less than 2. Then we can find then we can find a natural number n belongs to natural number such that x plus 1 by n belongs to S. X plus 1 by n belongs to S. That means x is the supremum. Now x square is less than 2. Then we can find a n belongs to n such that x plus 1 by n belongs to S. Will it possible to find such an n? Let us see. Now suppose x plus 1 by n belongs to S. Then what will happen? Then x is not an upper bound of S, right? So we want to prove existence of such 1 by n. Okay. Now existence of such a natural number n. Okay. Existence of such a natural number n. How to prove? So, for that, first we will note that one by n square and 1 by n, which is greater. 1 by n square and 1 by n. Of course, you are having 1 by n square is less than or equal to 1 by n, because you can take 3, 4, 5, etc. Now its square is going to be 9, 16, 25. Now you take 1 by 3 and 1 by 9, which is greater? Of course, 1 by 3, right? Now 1 by 4 and 1 by 16. Again, 1 by 4 is greater. So always what you are having is, so when n is equal to 1 means you will get 1. So I am putting the equality here. So 1 by n square is always less than or equal to 1 by n. So that take x plus 1 by n whole square. That's equal to x square plus 2x by n plus 1 by n square, right? Now I can replace this 1 by n square with 1 by n. So this value is less than or equal to x square plus 2x by n plus 1 by n, right? Now this can be written as x square plus 1 by n is common. I'm taking outside. So 1 by n into 2x plus 1. Now choose n so that 1 by n into this quantity, 1 by n into 2x plus 1 is less than 2 minus x square. Okay, so select n so that 1 by n into 2x plus 1 is less than 2 minus x square. Then we get x plus 1 by n whole square. This value is less than x square as such. X square plus, I can replace this with 2 minus x square, right? Plus 2 minus x square. Now simplifying, I will get this as 2. Now what I got is x plus 1, which implies x plus 1 by n whole square is less than 2. Now by our assumption, x square is less than 2. Okay, let it be here. Hold as verification A. Now by our assumption, what is the assumption? X square is less than 2, right? Therefore 2 minus x square, x square is less than 2, so 2 minus x square is greater than 0, right? Therefore 2 minus x square by 2x plus 1, this value is also greater than 0. What's the reason? Listen, 2 minus x square is greater than 0, right? So from here you get 2 minus x square greater than 0. Where is it? Yeah, from here. Where is 2 minus x square greater than 0? So 1 by n into 2x plus 1. This quantity is greater than 0, right? 1 by n into 2x plus 1. See, you can take from here. This value is less than or equal to this plus this. This is always a positive value, right? This is also positive. Therefore, this value should be positive. Okay, so 1 by n into 2x plus 1, this value should be greater than 0, which implies this 1 by n is always positive. So 2x plus 1 should be greater than 0. It should be positive, right? So that we are using here. So 2 minus x square by 2x plus 1. Now this value should be greater than 0. right? So we are having this value. Then by corollary, 2.4.5, what you are having of Archimedean property. I'm saying Archimedean property, we get their existence n belongs to n such that 1 by n is less than this quantity. 1 by n is less than 2 minus x square by 2x plus 1. So we are having a 1 by n which is less than 2 minus x square by 2x plus 1. Okay, so what's the thing we want to find, right? We want to have a 1 by n such that x plus 1 by n belongs to s. So x plus 1 by n square we have found out, and that is x plus 1 by n. So that value is less than 2 minus x square by 2x plus 1. So x is, so what about this value? You're having x plus 1 by n. Okay, so you have started with x plus 1 by n, and you are getting, this means x plus 1 by n's value. See, so such a n, we will get x plus 1 by n square is less than 2. That means x plus 1 by n belongs to your set S, right? Thus, x plus 1 by n belongs to S, which implies where x is which implies your x is not an upper bound of S. This is by A. Okay. Now x is not an upper bound of S. Now which is a contradiction? Which is the contradiction to the fact that x is the supremum. X is the supremum. Therefore, x square less than 2 is not possible. So x square less than 2 is not possible. Now what we want to check? We want to check x square greater than 2. Will it be possible? So next we will assume that x square greater than 2. Now assume that x square is greater than 2. Note that x minus 1 by m all square, which is equal to x square minus 2x by m plus 1 by m square. Okay, now this quantity is greater than, I can neglect this one, right? So it is x square minus 2x by m. Okay, I have neglected this quantity. Anyway, it should be a positive quantity, right? So this quantity should be greater than x square minus 2x by m. Hence, if we can choose m such that 2x by m is less than x square minus 2, then you will get this value is greater than 2, right? Hence, if we can choose m so that 2x by m is less than x square minus 2, then we get x minus 1 by m all square. This value is greater than, see, x square minus, this value is less than 2x by m is less than x square minus 2. So minus x square minus 2 will come. So this will result 2. So which implies x minus 1 by m all square, this value is greater than 2. So for this as your equation, A or B, right? A we have already used. Now by our assumption, so we want to check whether there exists such a m or not. 2x by m less than x square minus 2. If this is the case, means we have already assumed this value x square greater than 2, right? And x is the supremum. So now we are getting that x minus 1 by m belongs to S. Now by our assumption, now by our assumption, x square is greater than 2, right? Which implies x square minus 2 is greater than 0, which implies x square minus 2 by 2x. This value is greater than 0. What's the reason? Since x is greater than 1, right? Supremum. Since x is greater than 1, 2x is greater than 2. Anyway, it should be greater than 0, right? 2x is greater than 0 we can have. So, this is positive quantity, this is positive quantity. So, this quotient is also positive. Hence, by the Archimedean property, hence, by the Archimedean property, we can have, there exists a m belongs to n such that 1 by m is less than x square minus 2 by 2x. Now, for this choice of m, what we have? For this choice of m, we have what should be x minus 1 by m whole square. X minus 1 by m whole square. So we have said that by your equation B. Yeah, this is greater than 2. If we can select such an m. Okay, so we are having this m is less than x square minus 2 by 2x. So when you are having, see here, x square minus 2x by m you are having. So this value is less than, sorry, this value is greater than x minus 1 by m value, which value is greater than 2 by your condition B. X minus 1 by m whole square is greater than 2. So this value is greater than 2 by B. Now if an S belongs to capital S, then what you're having is S square is less than 2 and this value is less than x minus 1 by m square, which implies your S value is less than x minus 1 by m. This follows from by 2.1.13, because if a b greater than 0 and a square is less than b square, then a less than b we have studied there, right? So from this 2.1.13 we will get this, which implies x minus 1 by m is an upper bound for S. Is an upper bound for S, for capital S, right? Since we are taken a smallest arbitrary and we are getting that S value is always less than x minus 1 by m. That means x minus 1 by m is an upper bound for S. Now this is a contradiction. Why? We have assumed that x is the supremum. Now which contradict the fact that x equal to supremum of S. Therefore, we cannot have x square greater than 2. Thus, x square less than 2 is not possible and x square greater than 2 is also not possible, which implies x square equal to, or this implies there exists a real number x such that x square equal to 2. So we have proved the existence of the real number root 2. So what are the steps we have adopted? First we have taken a set S First we have taken a set S such that whose members have square is less than 2. And we will say that this set is non-empty. Oh, I have written as equal to empty. It is non-empty, right? So S not equal to empty. So S not equal to empty. and 1 belongs to S. Also, S is bounded above by 2. So this is a bounded above set, then it should have a supremum. And we are taking that supremum as X. Okay. Now my supremum value is always greater than 1 because 1 is a member in this. Then I should have my x square value is either less than 2, greater than 2 or equal to 2. And I will examine uh, x square less than 2 and x square greater than 2. And we will find that these two possibilities are not possible. So only existing possibility is x square equal to 2. Now we will prove that x square equal to 2. So for that, first assume that x square is less than 2. Now what you're going to do is x square is less than 2 we will assume. We will assume x square less than 2. And we will arrive at a contradiction to the fact that x is a supremum. Okay. Now we can find a 1 by n or n belongs to capital N such that x plus 1 by n is also belongs to S. So this is a contradiction, right? Because we are having x as a supremum. Now x is a supremum means x is the least upper bound, right? So once you are getting x plus 1 by n belongs to S means, which implies x is not an upper bound itself. So we will get a contradiction. Now how to find this 1 by n that we are explaining here. Existence of the natural number n. Okay. And similarly, what you're going to do is, in second stage, we will assume that x square is greater than 2. And we will get the resistor m such that x minus 1 by m square is greater than 2. Okay. Now from these two, we will have your x minus 1 by m whole square is greater than 2 we have. So that means this is a value in, or this is a number in your S. Now you have took an arbitrary value and this value is less than x minus 1 by m. Then x minus 1 by m is an upper bound for S, which again a contradiction since x is a supremum. So we will say that x square less than 2 is also not possible, x square greater than 2 is also not possible. So only possibility is that x square equal to 2. So I'm winding up today's session here. Thank you for your patient listening. Thank you.